Okay, so at an airport parking garage, the cost to park is $15 for the first day and then $10 for the subsequent days. So select all the functions that can be used to do the total parking. So this is an interesting one because this is something that you guys could, it's a linear function, right? You have an initial condition, right? So you guys could already do this, like your initial condition and then the rate. So this should be like y equals mx plus b. But by the way, this is what we call the explicit form of the sequence. So where m is the rate of change, well, what's the rate of change? $10 per day, right? $10 for each subsequent day. So it'd be $10 times x, and what did you start off with? $15, right? But here's the thing. On the first day, does x equal 1 or does x equal 0? So if x equals 1, you got to think about that. How do I write this? Because if x equals 1, that changes it to $25 after the first day. So because and it's very subtle, does 1 represent the first day or does 0 represent the first day? Well, since we're talking about sequencing, we're going to want P of n to represent the total number of days. So the first day, n equals 1. So I've got to adjust this to equal 15 on the first day, right? So how do I adjust that? Well, that's what's going to equal 15. In other words, when I plug in 1, and let's use the notation they tell us to. They want us to write this as a function, p as a function of n. So the parking as a function of the number of days would be equal to 10 times n plus 5, right? Where p of 1 is equal to 10 times 1 plus 5, which does equal 15. Let's double check that for the second day. Well, the second day should cost $25. Let's see if that works. 2. 10 times 2 is 20 plus 5 does equal 25. And the third day should be 35 days, right? And so we'll check that. So 10 times 3 plus 5, 3 times 10 is 30, 30 plus 5 is 35. So our sequence should be 15 for the first day and then $10 each additional day. So that works, okay? So then if I look, this one works. Okay, that one works. And then what about another one? So this is the explicit, right? But remember, we've got a recursive one. So the recursive one works like this. We start off with the first term. P of 1 is equal to 15. Well, what am I adding to that? Well, P of 2 is equal to P of 2 minus 1 plus 10, right? Because we're adding 10 to this. And then we're adding 10 to this. So this is what we call the recursive. Right? And then that is equal to P of 1 plus 10, which is equal to 15 plus 10, which is equal to 25. And then you repeat that process and you repeat that process. So if I were to generalize that recursive notation, I would say that P of n is equal to P of n minus 1 plus 10. And then noting that my first term is 15. So with the recursive, you identify the first term. So this one here, I think, is also valid. Why? Because our first term is 15, and then we're just adding 10 to the previous term. So this is the recursive formula. And that's it for that one.